All right, I just want to go ahead and pick up where we were leaving off. We were going to start with grouped data. And as we do this group data, I'm going to review a little bit about the unit that you're doing on your own with frequency diagrams and frequency distributions. I'm not going to go over everything, but a little bit about the frequency distributions. So with group data, we have our central tendencies. And we have a list of data for NFL players. And this data represents millions of dollars for their bonuses. And we have a list of data, and we want to organize that data in a table. That would be the first thing with group data. Now you'll notice some of the items repeat, some of them don't. And what we want to do is to collect that data in a table. So first in the table, we want to organize the data, the bonus amounts in numerical order. So from least to greatest, those bonuses amounts go from 10 million, 11.3 million, 12.4 million, 14, 18, and then we jump way up to 34.5 million. And then to kind of help us organize this data, we're going to make little tally marks as we go through the list of data and we record it in the table. So when we record 14, we put a tally mark. When we record 18, we put a tally mark. There's 14 again, so it has another tally mark. 34.5, we have a tally mark. 11.3, a tally mark. 10, a tally mark. 34.5, a tally mark. 11.3, a tally mark. 10, a tally mark. 11.3, a tally mark. 12.4, a tally mark. 10, a tally mark. 14, a tally mark. 10, a tally mark. 18, a tally mark. And so I would mark off my data as I go because that helps me to know I've got each data. And then the tally marks help me to indicate a count for each item in the table. And so now I can record the frequency. So for 10 million, there are 4 of those items. For 11.3, there are 3 of those items. So 12.4, there is only 1 frequency for that item. So for 14, there are 3 of those items. 18 million, there are 2 of those. And 34.5, there are 2 of those. So this frequency table is a distribution table or a frequency distribution table of our data. And that's just quickly how you would do a simple frequency distribution table. And that's one of the things that's covered in the unit that's posted for you to study on your own, is how to do a grouped data frequency distribution table. So that just quickly reviews that particular component of that unit. Now, once we have the frequency distribution table, we want to be able to compute our central tendencies for that data. So we've organized it in the table. Now the formula to calculate the mean. You'll notice it looks similar to the formula for a regular mean, except this F is thrown in there. Now, what do you think the F stands for? It stands for the frequency. So we would have to multiply the frequency times the data item and then add all that up and divide it by the number of items. So first of all, let's get a sum of the frequency. So we would add all these items up and find out there are 15 items in our data group. And again, we could count each of these items individually as well to find that amount. So to find the mean first, then that means that we're going to do the data item times the frequency. So we have 4 times 10 million plus 3 times 11.3 million plus 1 times 12.4 3 times 14 plus 2 times 18 plus 2 times 34.5. And all of that will be divided by the number of items that we have, which is 15. So as we continue, when we do all that calculation on top, we get 233.3 divided by 15, which is going to give us 15.57. Now, why do we go 2 places past the decimal? In this set of data, we go to the tenths place. So our rule of rounding, we go 1 place or 1 digit beyond that. And so that's why our answer is 15.57. So that's how we calculate our mean for a grouped set of data. Now, how do we find the median? The median is still going to be the middle number. So since we have 15 items, 15 divided by 2 gives us 7.5, which means the 8th item is the median. And so we count down from the frequency. Since we have them listed in numerical order, we have 4 plus 3 is 7 plus 1 more. The 8th item falls at the item 12.4. And so that gives us our median. For the mode, that one's pretty easy. Mode is the group with the highest frequency. And so the group with the highest frequency was the group with 10. So 10 million is the mode. Mid-range, the highest value was 34.5, the lowest was 10. So we still do that the same way, the min plus the max divided, which gives us 44.5 divided by 2, which is 22.5 for the mid-range. So that gives us an example of how to find each of the central tendencies using a frequency distribution. Now also, in the unit that you're doing on your own with frequency distributions, Sometimes group data has what we call classes. And the classes have a range. Now, our group data classes here are each of these particular items. Our group data with a range may be different. So if we have a group data that has a range, then we have to find the midpoint of that class and we use that for the data value. So for example, we have a class range from 10.5 to 15.5. The 10.5 is considered the lower limit or the lower boundary. Those are just terms that's covered in that particular unit. The 15.5 is considered the upper limit or boundary. And we need to find the midpoint for this range. In order to find that midpoint, it's kind of like finding a mid-range. We're going to do 10.5 plus 15.5 divided by 2. And that's going to give us 26 divided by 2, or 13. So 13 would be the data value that we use. So, for example, up here, when we were multiplying 10 times 4, and this particular class, if it had a frequency of 6, we would use 6 times 13, the midpoint of that range, in order to help us find the mean of that data. So that's how you would handle a grouped set of information there. Okay, and so that may make a little more sense when you go back and spend some time looking at your frequency distributions and looking at those group data. Help you put that together. All right, the next thing we want to cover is a weighted mean. This is used a great deal in calculating GPAs. That's not the only place that you do weighted means, but that is one place in particular. It is similar to group data, but it's not exactly the same. So if we were wanting to find our GPA, and this is how you would find your own GPA here at school. If you were taking English this term or this semester, you've had 2 terms. So if we were looking at all our classes for both terms, and your English was 3 credits, and you made an A in English. And then you took a psych class and it was 3 credits, and you made a C in Psych. And you took a biology class, and biology a lot of times has the lab with it, so you get 4 credits, and you made a B. And you took a PE class, and it rained all the time, and you never went to class, and you made a D in it, but it was only worth 2 credits. So one of the things you need to know is how much does each of the weights mean? So typically, an A is 4 points, a B is 3 points, a C is 2 points, a D is 1, and of course an F is 0 points. And so to compute your GPA, you will multiply your credit times the value of your grade. So in English, we had 3 credits times the A, which was 4 points. And then for Psych, it was 3 credits times the C, which was 2 points. For biology, that was 4 credits times the B, which was 3 points. For PE, that was 2 credits times the D, which was 1 point. And what we're going to do is to divide that by our number of credits. So we took 3, 6, 10, 12 credits. And so we have 32 divided by 12, which gives us a GPA of 2.67. And so that's how you calculate your GPA. Now, weighted GPAs are also done at places like where you go buy things that weigh and cost so much. So like if you go to a particular candy store and you buy this set of chocolate that costs $1.50 a pound, and you get a half a pound, and then you buy another kind of chocolate, say chocolate covered raisins, and they cost 75 cents a pound, and you got 3/4 of a pound, then your conglomerate cost of your bill is based on the weight times the cost of each item, and that gives you your overall bill cost. So that's doing a weighted means type of problem. So those are situations that you would use that particular type of calculation in. Okay, to finish up central tendencies, let's talk about properties and characteristics of each. There are pros and cons for each of them. So for the mean uses all the data. When you want to use all the data, the mean is a calculation that you would want to use. It varies little. When you add data points to it, there's not much change in how you calculate it. The thing about mean is it is used in many other computations. It is a unique answer. It is not one of the data values usually. We were talking about the grouped classes. If we had a class that went from 50 till infinity, this would not be a calculation that you could use in that open-ended class. And one of the most important things about the mean is it is considered to be not resistant to outliers. And we'll talk about outliers more in a minute, but outliers just means extremely high or low values. What that means if you had a very high number in your group of data or a very low number value, it is going to change the value of the mean significantly. The median. It gives a midpoint, that is a balance point. It's going to be even on both sides. It divides your data into two parts. The upper and the lower halves. You can use this calculation in an open-ended class. And the median is resistant to outliers. Often, the median is one of the actual data values. If it's an odd number of data values, it is going to be one of the data values. If it's an even number, then it's going to be something that's different. For the mode, you use it when you need evaluation of the most typical case. It is one of the easiest to compute. You can use it with qualitative data. The others you can't really use with qualitative data. It is not a unique value because it's going to be one of the data. But it does not always exist. It is resistant to outliers. And last, with the mid-range, it is easy to compute. It gives a middle value. It is not resistant to outliers. In fact, it is probably most affected by outliers because it's going to use the max and the min. It's going to be using the outliers. And so that finishes us up for measures of central tendency. Our next topic is measures of position. We're not going to have time to finish all of this, I don't think, before we finish today. So we'll get through what we can, and I'll post the rest in our notes. Measures of position is kind of like it sounds. It gives us a location within the data. So kind of like the name sounds, it's going to give us a position within the data. One of the first ones that we're going to look at is percentiles. Percentiles separates your data into 100 parts, regardless of whether you have 100 pieces or you have more than 100 pieces. It separates it into 100 parts. when you give a percentile rank, it means that if you're at the 30th percentile, that means that you have 30% below that value. So if you have 30th percentile, that means 30% below that. To find a percentile, you're going to count the number of values below a particular data value, add 0.5 to it, and divide it by the total number of values. And then we multiply it times 100. So here's our example. So we want to find the percentile for 12. The first step is to arrange our data in numerical order. So that would give us 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. How many items are below 12? There are 1, 2, 3, 4, 5, 6 items below 12. So that means we're going to do 6 plus 0.5 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items in our list total times 100, which means we get 6.5 over 10 times 100, which means we get 65% for our percentile. Now, what does that mean? A score of 12 is 65% better than the rest of the class. That's what I didn't tell you about the data. the data is quiz scores. All right, now if we want to go in the reverse, we know what the percentile is, and we want to know what the value is at that percentile. So that calculation is done by N times P divided by 100. And we want to remember to always round up. So we want to find which value is at the 25th percentile. We're using our same set of quizzes. And we want to find which data is at the 25th percentile. We still want them in numerical order when we do this. So our value is going to be the number of total items is 10 times the percentile 25 divided by 100 is going to give us 2.5. So when we round up, that gives us 3. So the value at the third position in the list is 5. So the 25th percentile value is 5. All right, so that's finding percentiles. Any questions? Very quiet group this morning. All right, the next one we want to look at is quartiles. Quartiles means that we're going to divide the data up instead of 100 parts, we're going to divide it up into 4 parts, kind of like the prefix tells us. We use the symbols and the terms quartile 1, quartile 2, and quartile 3 when we're talking about quartiles. Please note that quartile 2 is the same thing as the median. You find it the same way, it is the same value, they are the same thing. To find quartiles, we want to find the median, which is quartile 2, which divides your data into 2 parts. And then find the median of each half. The lower half will be quartile 1, and the upper half will be quartile 3. So let's look at an example. Also remember, the key here is also to arrange your data numerically first. Before you can do anything, you have to arrange your data numerically. So arranging this data, that would give us 5, 6, 12, 13, 14, 15, 18, 22, and 50. First thing we want to do is to find the median of that data. So just like we did before, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 items. The median would be the middle number, which would be the 5th one. 1, 2, 3, 4, 5. So the median is 14. In this case, the median is the same thing as quartile 2. Now, that means 50% of the data is on this side of the median, 50% of the data is on the left side of the median. That's important to know. Sometimes you will have questions that will ask, what percentage of the data is on the upper half? What percentage of the data is above quartile 2? Now, from the median on the lower half, we want to find quartile 1. So that's not including the median. These data items, which leaves us with 4. Well, that's an even number. So that means that we have to do the sum of the 2 in the middle, 6 plus 12, divided by 2. It gives us 9. And that represents quartile 1. Same thing on the upper half. There's 4 data values on the upper half. So 2 in the middle, 18 and 22. We're going to add them together. Divide by 2. And we're going to get 20. And that's going to represent quartile 3. Now, what does quartiles do to the data? The quartiles divides the data into 25%. So this is 25% of the data. This is 25% of the data. This is 25% of the data. And this is 25% of the data. So this 50% came from the median up. This 50% is from the median down. The quartiles, each section is 25%. And those percentages are important in terms of some questions that may be asked about how the data is affected by those quartiles. So it's not just about finding the location of the quartiles, it's also about interpreting the information from the quartiles. So quartile 1 had the value of 9. Quartile 2, which was also the median, had the value of 14. And quartile 3 had the value of 20. Now we extend that one further step to what we call the 5-number summary. And we include the min, the quartiles, and the max. And this gives us a quick summarization of the data. And so knowing what goes in the 5-number summary, the order of the 5-number summary is generally always given in that same order, the min, the quartiles, and then the max in numerical order. And then we use the 5-number summary to create box and whisker plots. And that's to illustrate the data distribution. A box and whisker plot is a relatively new invention in the world of statistics. It's only been around about 100 years, where a lot of things have been around hundreds and thousands of years. The box and whisker plot hasn't been around that long. And I want to quickly do one before we finish up, just so you can get an idea. We won't be able to do a modified box and whisker, and I will include that in your notes for you to see how to do one. So you will need to know about a modified box and whisker, but I'll only be able to show you right now how to do your box and whisker. Of course, you'd want to create a scale for your data. So I'm using your data above. Our data reaches from 0 to 50. I'm using a scale of 5. Whether you do your box and whisker vertically or you do it horizontally, it does not matter, but you create your scale first. You're going to use your 5-number summary to plot those 5 values to help draw your box and whisker plot. So my minimum value in my data was 5, and I'm drawing it above the scale so that I have room to actually draw the box and whisker. So not on the scale, but above it. So here's my 5. My first quartile was at 9. My second quartile was at 14, so I kind of have to approximate those values. My third quartile was at 20, and notice these dots are all horizontal in a line, and my maximum value was at 50. Now, the 3 middle values, quartile 1, 2, and 3, are what's used to draw the box. So I'm using those 3 values to create my box shape, and then a line through the middle quartile. The min and the max from the box represent the whiskers. And so that's how you create your box and whisker plot. Of course, it should have a title, and you should provide those extras that you should have on any particular graph. But that just kind of quickly shows you how to create your box and whisker plot. All right, so I kind of rushed through that very last part on creating your box and whisker plot, but I did want you to actually see that a little bit before we finished up today. Any questions on anything we went over today? A lot of it you've heard before. Just wanted to be sure you get that a little more in depth. In particular, the percentages when you're dealing with the quartiles, the percentages you may not have heard before. Okay, so I'll be posting some practice problems to go along with these, and probably a practice quiz that will cover the first 3 lessons for you to work on, just so you can have some repetition on practicing and see if you're doing them correctly. Okay? And that's kind of what you'll do for the weekend. Any questions there? All right. See ya.